Okay, here we go. 2.7, key concept, page 132 in your book.
It's amazing you knew it was up there.
That's right. 132, it's right up there. It's also down here, folks, if you wanted to see that.
Yeah.
There it is. Key concept, proportional equations. Number one, how does slope relate to the equation for a proportional relationship? Well, the equation you guys learned last year was y equals k times x, where k represented your constant of proportionality.
Constant.
Okay? Well, now, our equation is not k times x, it's m times x. Now, what just happened? I replaced the constant with the slope. So how does slope relate to the equation for a proportional relationship? Well, the slope is the what?
Constant of proportionality?
Constant of proportionality.
Do I have to write the whole word, Mr. Knoll?
Proportionality. Yeah, and spell it right. It drives me crazy when people can't spell right, especially when it's...
Is that the fourth thing you don't like?
You could say that.
Okay.
Well, no. I also hate it when people chew in my ears.
Ooh.
Okay, if you guys didn't know that,
ask him a story about it.
Do not eat Doritos in my ears. Okay? Anyways, let's get back to it. I don't want to be long-winded here. Okay? Look for relationships. What do graphs of lines in the form y equals mx have in common? How might they differ? Okay? What do they all have in common? Well, this is a proportional graph. What do they all have in common? They
origin?
all go through the origin. All of them. Every single one. Every one. Now, what do they have different? Well, they all go through the origin, but some of them go real
uphill.
Some of them go downhill. Some of them don't go up as fast. Some of them don't go down as fast. What is that called?
The steepness of a line, right? How steep or not steep? What is that?
What may differ?
The slope. Yes. May differ.
Be different. Okay?
Different.
What's always the same? They go through the origin. What could be different? The slope. Questions?
Not yet, Mr. Knoll.
Let's keep moving. We want to do this one. The table below shows the distance a train traveled over time. How can you determine the equation that represents this relationship?
Yeah, this one looks fun.
Well, how can we write the equation? We need to know in the equation y equals mx, we need to find the slope. Can we determine the slope from a set of ordered pairs on a table?
I think so.
Yeah. Yes,
I think so.
Folks, choose any two pairs. I don't care which two pairs. How about these? X-axis, Y-axis. That's a Y.
Didn't look like it.
So how can you determine the equation? We don't have to find the equation. How can you do this? What do we want to do with that table of values?
Find slope, people.
Find the slope.
Y minus Y over X minus X. Come on.
Find the slope. That's how we can. Okay? And once you find the slope, you plug it into that equation for M. Beautiful. Over here, we got this person hiking. Now, folks asked me about the time I went to Jackson, Wyoming, did some hiking out in Death Canyon. Okay? All kinds of beautiful stuff. But you don't want to hear about that, do you?
Yes.
You do?
But not right now.
The best is when we went, we crossed over, and over the mountains, you got to this place called the Alaskan Basin. Gorgeous. Absolutely gorgeous. Almost got lost out there, though. That would have been bad, because if so, I wouldn't be here. Ask me about it sometime. Daggone Rick. The Rick.
The Rick. Sabotaged.
He was trying to get me, folks, but he did it. The relationship.
He was trying on purpose to get you lost.
I think so. Between a hiker's elevation and time is shown in this graph. Find a constant of proportionality. Then find a slope. Why are they going to have me do both?
It's the same thing.
So we just got to find the slope, which is the constant of proportionality. How do we do that? We find 2 points.
1 comma R.
Well, do you want to do that one this time?
We could. We haven't done 1 comma R in a while, guys, have we?
1 comma 30. Folks, again, in a proportional relationship where the line goes through the point 0, 0, if you go over 1 unit and go up to where that line crosses, that is your unit rate. So our unit rate or our slope or our constant of proportionality, 30.
That's all we got to do. That is easy.
It's easy. Now, what does that mean? It means we are going up 30 feet every 1 minute.
Okay.
Write the equation of a line.
Y equals mx, folks. Replace the m with your slope.
So I'm going to get rid of the m, and I'm going to put the slope in there. There's your equation. Y equals 30x.
Nice.
That's it.
You mean it's that easy?
Yep. Now we got to graph this equation. That's a proportional equation, folks. So the first point we're making is right there at 0, 0. Now my slope is -1/2. -1/2. Rise over run. Which means from this point, I'm going down 1. A rise of -1 means go down 1 and over
2.
Run 2 units. There you
Watch
go.
your graphs. Not all graphs count by ones, people. Okay? Sometimes our graphs count by halves or twos.
I just graphed it. Okay, folks, there's page 132, key concept proportional equations, graphing and writing them. Good job.